person who started a pull request knows about that issue the most. So when it comes to merging, most likely we're going to have conflicts. It's really helpful to have that person on board. So they argue that the person who opens a pull request should be the one closing it as well. So there's really no right or wrong. It really depends on your team's culture. Now, here we have a few options. We can create a merge commit. We can squash and merge, or we can rebase and merge. We covered all these options before, so I'm going to go with a simple merge commit. All right, our pull request successfully merged and closed. Now we can delete this branch. Good. If we made a mistake, we can always come back here and restore the branch. Now back on Amy's machine, let's switch to master and then do a pull. Beautiful. Now let's look at the history. All right, so this last commit over here is our merge commit. Merge pull request number 1 from code-with-mosh/feature/login. Both my master and origin/master are pointing to the same commit. We no longer need this feature branch, so we should delete this local branch as well as the remote tracking branch. We already removed this branch from GitHub, so now we need to remove it from this repository. To do that, we type git remote prune origin. As I told you before, this removes the branches that don't exist on the remote, in this case, origin. So now if you type git branch -r, we don't have that remote tracking branch. Beautiful. Finally, we need to remove our local branch. So git branch -d feature/login. Now, what if you have conflicts when merging and closing a pull request? Well, once again, on Amy's machine, I'm going to start a new branch, add a commit, push it, create a pull request, and in the meantime, I'm going to create a conflicting change on master. So when we merge this branch into master, we get a conflict. So let's create a new branch called feature/logout. Now on this branch, I'm going to write hello to file1.txt. Let's commit the changes and say write hello to file1. Now let's push this branch. So push -u origin feature/logout. Now on GitHub, we have this new branch, feature/logout. We can start a pull request, but before doing so, let's add a conflicting change in master. So back to Amy's machine, let's switch to master and write something different to file1. So I'm going to write world to file1.txt. Now let's commit the changes, write world to file1, and then do a push. Of course, this doesn't have to happen on Amy's machine. Someone else might have a pull request that is open. That pull request might get merged into master, so master can move forward without Amy being aware of that, okay? Either way, we have a conflicting change. So let's go ahead. Now let's say Amy has finished her work, so she wants to start a pull request. So over here, we click on compare and pull request. Now look, GitHub is saying that it cannot automatically merge the changes because we have conflicts. But don't worry, we can still create the pull request. So let's give it a title, feature logout. I'm going to leave out the description, doesn't really matter. All right, now we have a pull request. At some point in the future, we want to merge and close this pull request. Now look over here. GitHub is saying this branch has conflicts that must be resolved. So here we have two options. We can use the command line or use the GitHub user interface. If you want to use the command line, the process is exactly like before. So someone who is in charge of merging, it could be Amy or someone else. That person first has to pull in the latest code. Then they have to start the merge process. They're going to get conflicts. They will resolve the conflicts, add a new commit, and then push it to GitHub. Exactly like before, nothing different. So in this lesson, I'm going to show you how to resolve conflicts on GitHub. That is very simple. So we click on Resolve Conflicts. Now on this page, we can see all the conflicting files on the left. In this case, we have a single file. And on the right, we can see our conflict markers. You have seen these before. So in this branch, feature/logout, we have added hello. On this branch, on master, we have added world. So we need to decide what changes we need. In this case, I'm going to bring the changes in both these branches. So let's delete the markers. We're left with hello world. Now, if you have multiple conflicts, we can browse through them using these buttons. Now, let's mark this as resolved. Good. So now we need to commit the changes onto feature/logout. So commit. Good. Now back to our pull request. down below, we no longer have that message saying there are conflicts. So we can go ahead and merge the pull request. Done. One of the features of GitHub that goes hand in hand with pull requests is issue tracking. So here on the Issues tab, we can track all kinds of issues like bug fixes, new features, enhancements, or any kind of ideas we want to discuss in the team. So let me walk you through a real example. I'm going to create a new issue. We give it a descriptive title like send email when someone signs up. Here we can write more details about this issue. We can also attach files. This is very useful. It's much easier than tossing emails around. So all the details for working on an issue are encapsulated in a single place. Now here we can optionally assign this issue to one or more people if we know ahead of time. If not, people can come in and assign issues to themselves. In this case, I'm going to assign this issue to myself. Okay. Now we can also add labels to this issue. So every Git repository has these labels by default. We have bug, documentation, duplicate, enhancement, and so on. We can also customize these labels. I'll show you how to do that in the next lesson. So let's add enhancement. Now, let's go ahead and submit the new issue. All right, here's our issue. On this page, we can have a conversation about this issue. So anyone in the team can come in and leave comments. This is very useful. Now, one thing that I love here is that we can link this issue with a pull request. With this, when we merge and close a pull request, this issue will be automatically closed. We can also assign this issue to a milestone. I'm going to talk about that later in this section. Now, if this issue is not linked to a pull request, we can always come in here and close this issue manually. Now, let's go back to the list of issues. So we have a single issue here that is an enhancement. You can immediately see that I'm working on this issue. This is very useful in Teams. So anyone can come in here and see who is working on what. And if someone doesn't have any work to do, they can always come in here and pick an issue. So I can come in here and assign this issue to myself if it's not assigned to someone else. Now let's go back. Now here we can filter the list by author, label, projects, milestones, assignees, and we can also sort the result in different ways. I'm not going to go through these. They're really simple. You can figure them out on your own. Next, I'm going to show you how to customize the list of labels. Let's see how we can customize the list of labels in a GitHub repository. So here on the Issues tab, we go to Labels. On this page, we can see all the default labels that exist in every GitHub repository. We can create a new label. Let's say refactoring. We can optionally give it a description and a color. Now, if you don't like this color, you can click here. GitHub automatically generates a new color that is reflected over here. Now let's create the label. Good. Now look over here. For the enhancement label, we have one open issue or pull request. So this is also another useful report. We can see all the labels and the number of open issues assigned to them in one place. Now let's talk about milestones. We use milestones to track the progress of various issues. So we can add a bunch of issues to a milestone and then see how much we have progressed in that milestone. So here on the Issues tab, we go to Milestones and create a new milestone. We give it a title. This can be anything that is meaningful to the team. For example, if you're working on version 2 of our software, the title can be 2.0.0. Now, optionally, we can give it a due date. So I'm going to set this to, let's say, 30th of September 2020. We can also give it a description and then create the milestone. So here we have one open milestone that is due by September 30th. Now over here, you can see the progress of this milestone. Now currently, we don't have any issues assigned to this milestone. So let's go to the Issues page and select this issue. And of course, we could select multiple issues and then put them in a particular milestone. Good. Now look over here. This issue is assigned to our version 2 milestone. Now let's go to the Milestones tab. Now look over here. We have one open issue, 0 closed, and we're at 0% complete. If I close this issue, our milestone will be complete. Let me show you real quick. So we go to the Issues. I'm going to select this issue and then mark it as closed. Okay, good. Now back to the milestones page. Look, our milestone is complete. This is a very useful report. So we have covered all the essential collaboration tools. Now let's see how we can work on an open source project. For this demo, I'm looking at this repository, Vidly MVC5, in my personal GitHub account. Let's say you want to contribute to this repository. Perhaps you found a bug or want to implement a new feature. So you come to the Issues tab. You can create a new issue and describe the bug or the feature you want to implement, or you can pick one of the existing issues. Currently, there are 79 open issues here. Now here's the problem. You don't have push access to this repository. Only I can push to it. So what you need to do is you go to the top and fork this repository. When you fork this repository, GitHub will take a complete copy of this repository and put it in your account. You have full control over that repository. You can create new branches, new tags, you can push your stuff, you can do anything you want, right? So currently, I'm logged in using my other GitHub account, that is Code with Mosh account. I'm going to fork this repository that is in my personal account. Take a look. It's going to take a few seconds. All right, look, we have a copy of this repository in my Code with Mosh account, which is forked from my personal account. So this is my repository in GitHub. Now I'm going to clone it on my local machine and start working on it. So let's go to code, grab the URL, and then clone this repository. Good. So now let's go to this directory. I'm going to start a new branch, git switch -c. We can call it bugfix. Now on this branch, I'm going to make a commit. So let's echo hello to our README file, and then make a commit and say update README. Good. Now I'm going to push this branch to my GitHub repository. So git push -u, the first time I'm going to push this branch, origin, which represents my forked repository, and then the name of the branch, that is bugfix. Now back on GitHub, my bugfix branch has recent pushes. So when I'm done with this branch, I can start a pull request. Now look over here. We're trying to compare the bugfix branch in this forked repository in my Code with Mosh account. We're comparing that with master of this base repository that is in my personal account. So starting a pull request is exactly like before. The only difference that we have here is that we have two repositories, the base repository, which is the main or the official repository, and my forked repository. Now we should give this pull request a descriptive title. So we can say bugfix in change password form. Of course, we can leave more details and then create the pull request. Now the maintainer of this repository, in this case myself, is going to get notified. So I'm going to come back here and have a conversation with the person who suggested these changes. So just like before, we can have a conversation, the maintainer can request changes, and the contributor can push new commits. At some point, when the maintainer is happy, they can come over here and merge this pull request. Now here's the interesting part. Currently, I'm logged in using my Code with Mosh account, so I'm a contributor to this repository. Now look, I cannot merge and close this pull request. Only the maintainer can do this. So on this other browser window, I'm logged in using my personal account. And look, we have 4 pull requests. And here's the last one that I just created using my other account. So I can look at this pull request, go through changes with the contributor. At some point when I'm happy, I can merge and close this pull request. So here's the repository for an open source project. We forked this repository to contribute to it. Now there's a problem. This forked repository is not connected to the original or the base repository. So from time to time, it can get out of sync with the base repository. If other people contribute to the base repository and add new commits to the master branch, we are not going to be aware of those new commits. In this lesson, I'm going to show you how to keep this forked repository up to date. So in this local repository on our machine, we have a reference to our forked repository called origin, right? We can add another reference to the base repository and then use the pull command to bring in the new commits, and then we can push them to our forked repository. As simple as that. Let's see this in action. Earlier, we briefly talked about the remote command. With this command, we can manage the remote repositories. So currently we have a single remote that is origin, we can run git remote -v, that is short for verbose, to see more details about these remote repositories. So here we have two channels, fetch for getting new objects and push for pushing objects. Both these channels are mapped to this URL. Now to add a new remote, we type git remote add. We give it a name like base, or a lot of people like to call it upstream. You can call it whatever you want. It doesn't really matter. Now we need to grab the URL of the base or the original repository. So here on my personal GitHub account, here's our Viddler repository. I'm going to grab the URL and then paste it over here. Good. Now let's look at our remote repositories. So we have origin and upstream. Once again, we can run remote -v. So you can see origin is pointing to Vidly in my Code with Mosh account, whereas upstream is pointing to Vidly in my personal account. Okay. Now let's say we made a mistake and we want to rename this remote repository. We simply type git remote rename. We want to rename upstream to base. That's better. If we're done with the remote, we can simply remove it. We type git remote rm, and then we type the name. All right, so we're done here. Now I'm going to go to my original or the base repository and make a new commit. So here on my personal account, I'm going to edit this README file. So let's add a new line of code and then make a commit. Good. So we added a new commit to the master branch of the base repository. Now I'm going to switch to my forked repository. Now on my Code with Mosh account, look over here. GitHub is saying that this branch, our master branch, is one commit behind the master of the base repository. So back in the terminal, we need to use the fetch or the pull command to bring in the new commit. So I'm going to use fetch for now. Now, early in the section, we used the fetch command without specifying the name of the remote. And I told you that if we don't supply the name of the remote, by default, origin will be assumed. Now, in this case, we don't want to fetch the commits from origin because that is our forked repository. We want to get the new commits from the base repository. So here we type base. Good. So we got a new branch called base/master. Now let's look at our history. So here's our local master branch, and here's the master branch of the base repository. So our local master is behind the master of the base repository. So we should merge base/master into our local master. So first we switch to master and then run git merge base/master. Now in this case, because the local master is not diverged from the remote master, we're going to have a fast forward merge. Take a look. There you go. Fast forward. Now let's look at the history one more time. Okay, so now our local master and base/master are pointing to the same commit. Beautiful. So our local repository is in sync with the base repository. Now we need to push the changes into our forked repository. So git push. Now, back on my Code with Mosh account on GitHub, when I refresh the page, this notice is going to go away. Take a look. Now GitHub is saying that this branch is even with the master of the base repository. Beautiful. So this is how we can keep a forked repository up to date. Now back to the terminal, it's always a good practice to merge the master branch into your local feature branch because this will reduce the chance for conflicts in the future. If there are changes in the master that will affect your work, you want to make sure that your work is on top of those changes. So we're going to switch to our bug fix branch and then run git merge master. We're going to bring in the changes in master into the current branch. Now look, we have a conflict. So by resolving the conflicts locally at this point in time, we'll reduce the chance for future conflicts when the maintainer of the project wants to merge and close our pull request. Let's see how we can work with remote repositories here in VS Code. Unfortunately, we have limited collaboration tools here compared to GitKraken, but let me walk you through the tools we have here real quick. So we go to GitLens. We talked about this earlier in the course. We can right-click on our repository. Here we have fetch, pull, push, and push force. Now, one thing that I like about GitLens is that it tells us how far we are behind or ahead of a branch in origin. So we're currently on the bug fix branch. I'm going to create a new commit, And then GitLens will tell us that we are one commit ahead of origin/bugfix. Take a look. So I'm going to change our README file and add a new line. Save. Now let's commit it and say update README. Good. Now back in GitLens, take a look. GitLens is saying we're one commit ahead. We can expand this folder and see the commit that we have to push to origin. So we can click on this icon and push this. Here we have three options. We can do a regular push, we can do a force push, or cancel. As I told you before, you should not really use a force push that often unless you have screwed something up. So let's go with a regular push. Good. Now the first time you're going to see this pop up saying the extension GitHub wants to sign in using GitHub. So let's allow that. Now we have authorized Visual Studio Code to access GitHub. Let's go with that. And then confirm. Here we have to enter our password. Okay, perfect. Now back to VS Code. It's saying that GitHub authentication wants to open a URI. That's totally fine. Let's open it. Good. Now we have this prompt here saying, would you like code to periodically run git fetch? I find this pretty useful because it tells us how far we are behind origin. So let's allow that. Good. So we're done with pushing. Now, unfortunately, here we cannot push tags or branches, at least not at the time of recording this video. So to push a branch or a tag, we have to go back to the terminal. Another tool we have here is remotes. So here we can see we have two remotes, base and origin. We can add a new remote or rename or remove an existing one. So these are pretty much all the collaboration tools we have in GitLens. GitKraken is a lot better. We'll look at that next. Now let's look at the collaboration tools in GitKraken. So currently we are on the bugfix branch. We can right-click this branch or any of the branches. Here we have pull, push, and set upstream. With set upstream, we can map a local branch to a branch in a remote repository. Now here, unlike VS Code, we can push our branches and tags. So I'm going to create a new branch off of master. So I'm going to right-click this commit, which is the last commit on master. Then create a new branch called feature. All right, now let's make a small change and add a new commit to this branch. So I'm going to go to README file and write something here. Save. Now let's make a commit and say update README. Good. So our feature branch has moved forward. Now we can push this branch directly to our GitHub repository. So right click, push. GitKraken is asking the name of the remote branch. So I'm going to accept the default value here, that is feature, submit. Now the first time we want to push, we have to get an authorization token. Here we have three options: refresh token, retry without OAuth, and cancel. I'm going to refresh my token. Just like before, we have to authorize GitKraken to access GitHub. So let's continue and confirm. Good. Now back to GitKraken, we pushed successfully, beautiful. Pushing tags is exactly the same. So here on master, I can right click and create a new tag. Let's call that version 1.0. Now we can right click this tag and push it to a remote repository. Here we have two remotes, base and origin. We can push to one of these repositories or to all of them. So GitKraken has a lot more features than GitLens. Here we can also manage our remotes. So on the left side, we currently have two remotes, base and origin. We can add a new remote, pretty straightforward. One more thing I love about GitKraken is managing pull requests. So here we have another panel for our pull requests. So here are all the pull requests we have in our base repository. We can easily create a new pull request. So let's say we're done with this feature branch. Now we want to start a pull request and tell the maintainer of this project, bring our changes into the original repository. So we right-click this branch and then start a pull request to base from origin/feature. Take a look. So we are starting a pull request to merge the feature branch of our forked repository into the master of this base repository. Now, just like before, we can give this pull request a title, a description, and then create the pull request. Perfect, we're done. Now here in the original or the base repository, we can see our new pull request. It's right here. One of the great but also dangerous features of Git is that it allows us to rewrite our history. We can drop or modify commits, we can combine or split them, and so on. That's what we're going to talk about in this section. We're going to start off by talking about why and when to rewrite history. Then I'm going to show you how to undo or revert commits. We already covered these before, but we're going to revisit them with a bit more depth. Next, you're going to learn how to use interactive rebasing to rewrite history. With interactive rebasing, we can modify commits, drop them, combine or split them, and so on. We're also going to talk about recovering lost commits. There are a lot of fun things we're going to talk about, so let's jump in and get started. Let's start off by talking about why we need to rewrite history. Well, we have to ask, why do we need the history in the first place? We need it to see what was changed, why, and when. If our commit messages are not meaningful, or if our commits are too large and contain unrelated changes, or if they're too small and scattered all over the history, then we're not going to be able to extract meaningful information from the history. We want a clean, readable history that tells the story of our project, how it's evolved from day one. That's where rewriting the history comes in. If we have small related commits, we can squash them into a single commit that represents a logical change set. On the other hand, if we have a large commit that contains a lot of unrelated changes, we can split that commit into a bunch of smaller commits, each representing a logically separate change set. We can also reward commit messages so they're more meaningful. If we made commits by accident, we can drop them. We can also modify the content of our commits. So if you forgot to include a file in a commit, we can go back and modify that commit. These are the operations we can perform in Git to produce a clean, readable, and meaningful history. But rewriting history can be a dangerous operation, and you need to know what you're doing before touching the history. That's what we're going to talk about next. So I told you about the benefits of rewriting history, but before doing so, you should remember the golden rule of rewriting history. Don't rewrite public history. This basically means if you have pushed your commits to share your work with others, those commits are considered public and you should not modify them. Let me explain why. Let's say our local and remote repositories are in the same state. They have the same history. And now we want to modify B. Here's what you need to understand. Commits in Git are immutable, which means once we create them, they cannot be changed. So if we try to modify B, Git will create a new commit, let's call it B star. So B is going to stay in Git's database in case we screw something up and we want to recover it later. Now let's say we want to do a push to share our change with others. What do you think is going to happen? Git is going to reject our push. Can you tell why? At this level, you should be able to answer this question. If not, pause the video and think about it for a few seconds. Here's the reason. Look at the shape of our history on the left side. Our master branches have diverged. This is exactly the same scenario where we try to push after someone else has pushed to origin. So there are some changes in origin/master that don't exist in our master. In this case, first we have to merge origin/master into our local master, and then we can do a push. Now our local and remote repositories have the same history. But look at what we have done here. We have created this nonlinear, noisy history. These two commits, B and M, are completely unnecessary. We wanted to modify B and replace it with something better. So why should we keep it in history and share it with others? So now let's look at an alternative solution. We're back in the previous state before we did a push. So if we do a push, our push is going to reject it. Here we can use the force option and force Git to overwrite what is in origin with what we have locally. So in origin, Git is going to drop B and replace it with B star. And then in our local repository, Git is going to attach origin/master to B star. Now we have a simple linear history. So you might think this is great. We should use the force option all the time. That is not true. Let's forget about our local repository for a second. Imagine here's John's repository before we did a push. So John is not aware of our new commit, B star. In his repository, he only has A and B. So he adds a new commit on top of B, and then he tries to do a push. What do you think is going to happen? You know the answer. John's push is going to get rejected because once again, his master branch is diverged from origin/master. So there are some changes in origin, in this case B star, that John doesn't have in his local repository. So first he has to do a pull to bring in B star and then merge it with his master. Now he can do a push to share his work with others. But look, once again, we have created this noisy, nonlinear history. So remember the golden rule. Don't rewrite public history. Once you push your work, it's public, it's final. So you should not change it unless you have a strong reason for doing so. Rewriting the private history in your local repository is perfectly fine. And in fact, it's actually a good practice. So you should always clean up your work or your private history before sharing it with the rest of the world. So back to our repositories. Currently, both our local and remote repositories are in the same state. Now let's say we add a new commit on top of B. This new commit is private because we haven't shared it with anyone else. We haven't pushed it yet. So we can change the commit message or the content. We can even drop this commit. No one is going to get affected. In this section, we're going to work with a different repository called Mercury. If you want to follow along with me, you can get this repository right below this video. Now, let's look at our history. So here's our initial commit. After that, we have render restaurants, the map. Here we have a wording issue. The word on is missing. So the message should have been render restaurants on the map. So later we'll come back and fix the wording issue. After that, we have fix a typo. This is a common issue that I see quite a lot in people's repositories. Technically, this commit shouldn't be here because we shouldn't have made the typo in the first place. So commits like this are just noise in the history. So later I will show you how to combine these two commits to make our history clean and readable. Now look at the next commit. Change the color of restaurant icons. What's the problem with this? Well, once again, this is part of the same unit of work. So ideally, we should combine all these three commits into a single logical commit. Next, we have add a reference to Google Map SDK. What do you think is the problem with this commit? The problem is the position of this commit in the history. Because here we're rendering the restaurants on Google Map, but then we're adding a reference to Google Map over here. So that means if we check out this commit on its own, our application is not going to work because at this point in time, we don't have a reference to Google Map. So here we have two solutions. We should either move this commit down and put it before rendering restaurants, or we can combine these two commits together. After that, we have a work in progress commit. Again, very common issue. I see it all the time. Commits like this are just noise in history. Later in the future, let's say a week or a month from now, if we look at our history to see what was changed and why, we're not going to extract meaningful information from commits like this. So we should either drop this commit or change its message. Now look at the next commit. Update terms of service and Google Map SDK. Here we have a commit that combines two separate kinds of changes. Updating the terms of service got nothing to do with updating Google Map version. So ideally, we should split this commit into two separate commits. Next, we have another work in progress commit, followed by a commit with a mysterious message. What does period mean here? Nobody knows. So once again, we should either drop this commit or change its message. So throughout this section, I'm going to show you various tools to clean up this history. We're going to start off by undoing the last two commits. We'll do that next. Let's say we decided that this last commit over here is useless and we want to undo it. Here we have two options. If we have pushed this commit to a remote repository, chances are other people have based their work on top of this commit. So we shouldn't remove this commit. Here we should use the revert command, and this will create a new commit that will undo all the changes in this commit. So we type git revert head. We'll talk about this in more detail in the next lesson. But let's say we haven't pushed this commit, so it only exists in our local repository. Here we can use the reset command to remove this commit from the history. Now, I know that we have talked about this before, but let's revisit it one more time because I want to make sure you really understand how it works. So we type git reset --hard. I'm going to talk about this option in a second. And then we type the target position for our head pointer. So we want to move the head pointer from this commit to the commit before. So we type head ~1. Now, what is the hard option? Well, let's say we have two commits in our repository, A and B is the last commit because head is pointing to it. Now look at our working directory and the staging area. In both these areas, we have the same code that we have in our last snapshot, that is B. Now, if we reset the head using the soft option, Git will simply move the head pointer to the target location. But it's not going to touch our staging area and the working directory. Now, what is this state? This is the state before we committed B. So we have some changes in our working directory and the staging area, but we haven't committed these changes yet. So this is the effect of the soft option. Now, if we use the mixed option, Git will take the latest snapshot, that is A, and put it in our staging area. What is this state? This is the state before we staged our new changes. So we have some new changes in our working directory, but we haven't staged those changes yet. This is the effect of the mixed option. Now, if we use the hard option, Git will take the latest snapshot and put it in our working directory as well. Well, more accurately, it will put it in both our working directory as well as the staging area. So our new changes in our working directory are gone. So let me show you a simple way to understand and memorize the difference between these options. If we use the soft option, Git will only remove the commit, but it's not going to touch our staging area and the working directory. So we're going to have some changes in the staging area ready to be committed. If we use the mixed option, we go one step back. So our changes in the staging area will be unstaged. So we'll have some local changes in our working directory. And if we use the hard option, we go even one more step back. So Git will discard our local changes. This is how I've memorized the difference between these options. So let's see this in action. Before resetting the head, let's look at the content of the latest commit. So git show head. In our last snapshot, we simply added the word test in this file, terms.txt. Now let's reset the head using the soft option. So our last commit is going to go, but this change is going to stay in the staging area. So git reset --soft head ~1. All right, look, we have some changes in our staging area. We can verify it by getting a short status. So we have a green M, which means we have some changes in terms.txt. Now we can compare the staging area with the latest snapshot using the diff command. We talked about this before. So git diff -- cached. So here's the change in our staging area. Beautiful. Now if we use the mixed option, Git will unstage our changes. So before running git reset, let's look at our log one more time. All right, look, head is currently pointing to this commit. So our last commit is gone. Now let's type git reset -- mixed head. Note that I'm using head and not head ~1 because I want to keep head where it is. It's pointing to this commit. So when we use the mixed option, Git will take the snapshot that head points to and put it in the staging area. So this is going to unstage our changes, okay? And by the way, mixed is the default option, so we don't have to type it. Look, Git has unstaged our changes. So let's run a short status. Now we have some changes in our working directory. We can compare our working directory with the staging area using the diff command. So git diff without any arguments. There you go. So here's the change in our working directory. Now if we use the hard option, we go even one more step back. So this local change will be gone. Git reset --hard head. Our local change is gone and we have a clean working directory. Let's say we have pushed all these commits to a remote repository, and now we want to undo one or more of them. As I explained before, resetting the head is not an option here because we don't want to drop the commits that we have shared with others. So we have to use the revert command. Now, let's say we want to revert this commit over here. We type git revert head. We can also revert an earlier commit, like head ~2. This will revert this commit over here. We can also specify a range. Let's say we want to revert all the last 3 commits. First, we look at the parent of this commit. So that is this commit over here. So here we say revert head ~3 to head. Here's the tricky part. When we say head ~3 to head, we're referencing this range, but Git will actually revert the last 3 commits. So it's not going to include this commit over here, okay? Now when we run this command, Git is going to revert each of these commits one by one. Take a look. Let's go. All right, first it's going to revert this commit. I'm going to keep the default message as is. So let's close this window. Now Git is reverting the next commit. Once again, I'm going to keep the default message. So Let's move on. And here's one more revert operation. Let's go. All right, reverting is done. Now let's look at our history. Look, we have 3 revert commits, and this is very ugly. It's adding so much noise in our history. Wouldn't that be better if we reverted all these commits using a single commit? Let me show you how to do that. First, I want to reset the head to this position to get rid of these revert commits. So git reset --hard head ~3. Let's look at our history one more time. So we're in the same state as before, and we want to revert the last 3 commits. We type git revert. Now we're going to use an option called no commit. With this option, Git will simply add the required changes in the staging area. So for every commit that we're going to revert, Git will figure out the changes that need to be undone. Then it will apply those changes in the staging area. That's just like before. We're going to specify our range. So head ~3 to head. Now we can simplify this by dropping the second head. So with this, we're essentially reverting the last 3 commits. Take a look. So Git removed this file because we added this file in one of the last 3 commits. Now look, we have some changes in our staging area. So git status -s. Here's the reverse of all the changes across the last 3 commits. Now if you screwed something and we want to get out of this state, we can type git revert abort. Or if we're happy with our changes, we can use the continue option. Now in this case, I don't want to accept the default message because we are reverting multiple commits. So we should write a message that better describes the commits that we're reverting. In this demo, I'm going to say revert bad code. Save, close. All right, reverting is done. Let's look at our history. Now we have a single revert commit. Beautiful. So we can push this to the origin and share it with others. Sometimes we may screw up while resetting the head. Let me give you an example. So here's our history. I'm going to run git reset hard head ~6. Let's say this is an accident. Now let's bring up the history again. What happened to our commits? You may think that we have lost our commits. Well, I've got a good news for you. With Git, we don't really lose anything. All the information about our project history, all the commits that we have created, all of these objects are stored in our repository, even if we don't see them when looking at the history. So Git keeps all these objects for a while, and if they're not used anymore, then it will garbage collect them. So how can we recover the lost commits? Well, we have a great tool here called reflog. This is basically a log of how a reference has moved in our history. If we don't supply any options here, Git will show how the head pointer has moved in our history. Take a look. Now you might think this looks like a scary movie, but trust me, this is easier than you think. So from the top, look at the first entry in this log. Every entry has a unique identifier. Here's the unique identifier of the first entry. Here's the unique identifier of the second entry. Now, in front of the unique identifier, we see a description of what happened. So just a few seconds ago, we used the reset operation to move the head to this new position. Now, after this operation, now head is pointing to this commit over here. We can verify it. So look at our history. Head is here and is pointing to this commit, AF26. We can verify it here. Now look at the second entry in the log. Before the reset operation, we made a commit with this message, revert bad code. After this operation, the head pointer was at this location. So to recover the lost commits, we can reset the head back to this location. So I'm going to copy this. Here we can use the commit ID or the unique identifier of this entry. So we type git reset hard. In this demo, I'm going to use the entry ID. Good. Now head is at this location called revert bad code. Let's look at our history one more time. All our commits are back. Beautiful. Now we can use the reflog to see how other pointers have moved in our history. So let's say we have a branch called feature. We can type git reflog show feature, and this will show the history of the feature pointer. There are a lot of cases where we make a commit, but then we realize that we made a mistake. perhaps we left a typo, or we accidentally included a file in our commit. In these situations, we don't really need to make another commit. We can amend or modify the last commit. Let me show you. So let's echo cafes to map.txt. Now let's make a commit and say render cafes on the map. Good. Now let's say we made a mistake and we should have echoed blue cafes on map.txt. So let's open map.txt and make the required changes. Blue cafes. Good. Now, back in the terminal, first we need to stage the changes. So git add period. Good. Now, to amend the last commit, we type git commit -- amend. We can supply a new message, or we can just enter and accept the previous message. I'm happy with the message, so let's close this. Back in the terminal, our last commit is amended. Just remember, we didn't really modify the last commit because, as I told you before, commits in Git are immutable. So even though on the surface we amended the last commit, Git actually created a new commit, okay? Now, let's look at the history. So here's our last commit. Let's look at the content of this commit. So git show head. Take a look. Now we have blue cafes. Now, as another example, let's say we forgot to include a file in the last commit. How can we do that? The exact same way. So I'm going to echo hello to file1.txt. Now, let's stage the changes and amend the last commit. We're going to accept the same message. So let's move on. Now, let's look at the history one more time. Here's our last commit. We didn't add an additional commit. Let's look at the content of the last commit. So here we have two changes. We introduced a new file, file1.txt, with this content, and we added this new line to map.txt. Perfect. Now, let's say we accidentally included file1.txt in the last commit. How can we remove it? Well, earlier we talked about resetting the head. I talked about 3 different options: soft, mixed, and hard. I told you that if we use the mixed option, Git is going to unstage our changes, but all of our changes are going to stay in our working directory. So I'm going to reset the head using the mixed option to head ~1. Now our working directory is dirty, so let's run a short status. We have 2 changes. We have some modifications to map.txt and a new untracked file. Let's say we don't need file1, so we can run git clean fd. We talked about this earlier in the course. With this, we can remove untracked files from our working directory. All right, so file1 is gone. We are left with the changes in map.txt. So let's stage the changes and then make a commit. Now here, I'm not going to use the amend option because we've removed the last commit by resetting the head pointer. So here we should create a new commit and say render cafes on the map. So this is how we can amend the last commit. But how can we amend an earlier commit? We'll talk about that next. Let's see how we can amend an earlier commit. So look at this commit over here. Add a reference to Google Map SDK. Before going further, let's look at the content of this commit. So I'm going to copy the commit ID. Now let's run git show. So in this commit, we're adding this line to package.txt. Now let's say we forgot to include the license for Google Map. So we want to go back in history and amend this commit. Now let's pull up the history one more time. So to edit this commit, we're going to use interactive rebasing. As you learned earlier in the course, with rebasing, we can replay a bunch of commits on top of another commit. So here we're going to replay this commit and all the future commits on top of the parent of this commit, which is this commit over here. So I'm going to copy this commit ID. Now let's run git rebase -i for interactive. This basically means that we're going to interact with the rebase operation. So we're going to stop it, make changes, and continue. Now we paste the commit ID. All right, take a look. What we have here is a script. It contains a series of instructions about the rebase operation. So here we have instructions or commands like pick. Down here, you can see a legend of all the supported commands. So we have pick, reward, edit, and so on. As we go through this section, you're going to learn more about these commands. So in the script, we have all the commits that we're going to replay listed from the oldest to the newest. So up here is the commit that we want to edit, and down here is the latest commit. Now, I'm going to change this instruction from pick to edit. We can also edit multiple commits if you want to. In this demo, I'm going to edit only a single commit. So revert, save the changes. Now, at this point, you know that when we edit a commit, Git actually creates a new commit. Now, here's the interesting part. In this demo, even though we're editing only a single commit, all the commits that come after this commit will also be edited, or more accurately, recreated. Let me explain why. Imagine we have 4 commits in our history and we want to amend B. Git creates a new commit, let's call that B star. Now, C should point to B star, right? But this is not possible because commits are immutable, so the parent of C cannot be changed. In this situation, Git creates another commit that looks exactly like C, but it points to B star. By the same token, Git will create another commit that looks like D, but points to C star. So even though we only modified B, all the subsequent commits had to be modified or more accurately recreated. So remember, rebasing is a destructive operation because it rewrites history. So you should use it only for the commits that you haven't shared with others, okay? All right, back to our script. We're going to edit the first commit in this list. Now, when I close this window, the rebase operation will start. Back in the terminal, take a look. You've stopped at this commit. Add a reference to Google Map SDK. So because we told Git that we want to edit this commit, Git stopped here. Now we have a chance to amend this commit. So we're going to make the necessary changes. Then we're going to amend this commit and then continue with the rebase operation. So I'm going to echo license to license.txt, then add this change and amend the current commit. We're going to accept the previous message. That's good. Now, back in the terminal, we made a new commit. Now let's run git log, one line, all graph. Let's see what's going on here. We have 2 branches. In this branch, we have all the commits that we wanted to replay. Down here is the first commit. That is the commit that we wanted to edit. We modified this commit and Git created another commit with the same message up here. The rebasing operation stopped. So once we continue rebasing, all the subsequent commits will be replayed on top of this new commit, and then this branch will be discarded. Take a look. So we type git rebase -- continue, or if we screw up, we can always abort the rebase operation and go back to the previous state before we started the rebase. So let's continue rebasing. Good. Now let's look at the log one more time. We have a simple clean history. Now, if you paid close attention, you probably noticed that the commit IDs are different. So here's the new ID of the commit that we changed. Let's copy this and run git show. So now in this commit, we have 2 changes. We introduced a new file, license.txt, and we added this line to package.txt. Perfect. Now let me show you something interesting. I'm going to pull up the history one more time. So we added license.txt in this commit. Now, what if we check out the commit that was introduced later? Let's say this commit. If we check this out, you will see that our license file is still there, even though it was not in the original work in progress commit. So let's check out this commit. The head pointer is detached. Now let's look at the files in our project. Here's the license file that we just added. So here's what you need to take away. The change that we introduced in one of the earlier commits carried on throughout the rest of the history. All right, we're done here. So let's check out master. Now let's see how we can drop a commit. So let's say we want to drop this commit over here, our first work in progress. But before doing so, let's look at the content of this commit. So I'm going to copy the commit ID. Now let's run git show. All right, in this commit, we introduced a new file called terms.txt. And in this file, we added this line, draft. Now let's look at the next commit. So back to the log. Here's the next commit, update terms of service. So once again, let's look at the content of this commit. Git show. Here we have 2 changes. We have an update in package.txt. So we're updating Google Map version. We also have a change in terms of TXT. So we replaced draft with completed, okay? So here's the interesting part. Let's pull up the history one more time. What do you think will happen if we try to drop this commit? We're going to end up with a conflict. Here's the reason. By dropping this commit, we're essentially saying we never introduced this change. So we never introduced a file called terms.txt. Now, in contrast, the next commit says, hey, I have an update for terms.txt. So Git will not be able to replay all these commits. It's going to get confused. This is where we need to jump in, resolve the conflict, and then continue the rebase operation. So here's the commit we want to drop. We should start our rebase operation with the parent of this commit. So we type git rebase -i. Here's the commit. Then we type ~1, or we can also use a caret. That means the parent. So let's go with that. Here's the commit we want to drop. We can change the command from pick to drop, or we can just delete this line. Now, save the changes and back in the terminal. All right, look, we have a conflict, but don't get scared. This is much easier than you think. So let's run a short status. What's going on here? We have some changes in the staging area. We have an update to package.txt, and we have some local changes that are not staged. On the one hand, we're trying to delete this file. On the other hand, we're trying to update it. So these changes that you see here are actually going to go with the next commit. So let's pull up the history one more time. All right, look, the head is currently at this location. So it's in the detached mode. We told Git that we want to drop this commit. So Git is trying to undo the changes introduced in this commit. In this case, adding this new file, terms.txt. Now the changes that we have in the staging area are going to go when replaying the next commit. In this commit, we had two changes. We updated terms of service and Google Map SDK version. So now we need to resolve the conflict. We type git merge tool. We have two types of changes, a deletion and a modification. In this case, we're going to go with the modification because we want to keep that file in our history. So let's go with that. Now, let's get a short status again. So we have two changes in the staging area that are going to go with the next commit. So we're ready to continue the rebase operation. Git rebase -- continue. Also, as I told you before, if you screw something up or if you have a nasty merge conflict, you can always abort and go back to the state before you started the rebase operation. It's very easy. So let's continue rebasing. All right, here's the message for the next commit, update terms of service and Google Map SDK. So let's close that. We're done with rebasing. Beautiful. Let's look at our history one more time. So our first work in progress commit is gone. Now, as another example, I want to drop these two commits as well. So these are the last three commits. We can run git rebase -i head ~3. So we see the last three commits. Now I'm going to delete these two commits, save the changes, back in the terminal. In this case, we didn't have any conflicts. So let's look at our history one last time. All those ugly commits are gone. Next, I'm going to show you how to reword commit messages. Now let's see how we can reword commit messages. So earlier I told you that here we have a wording issue. Render restaurants on the map. So the word on is missing. Once again, we're going to start interactive rebasing. So I'm going to grab this commit ID. Now let's run git rebase -i, this commit, caret to represent its parent. All right, here's the commit you want to reward. Now we're going to replace the pick command with reward. We can also reward multiple commits. For example, let's say here we forgot to include the Google Map SDK version. So I'm going to use the reward command here as well. Good. Now when I close this window, Git will replay each of these commits. For every commit that we want to reward, it's going to stop and give us a chance to change the message. So close. All right, here's the first commit we wanted to reward. So render restaurants on the map. Good. Save. Close. Git replayed the other commits, and then it stopped at this second commit we wanted to reward. So here I'm going to add the version. Save. Close. And rebasing was successful. Beautiful. Now let's pull up the history. Now I want to emphasize this one more time. In this demo, we reported this commit, which caused this commit to be recreated. And that means all the subsequent commits were also recreated. So we have rewritten history. As I told you before, rewriting history is a destructive operation. You should do this only with the commits in your local repository. Next, I'm going to show you how to reorder commits. Earlier, we talked about the problem with this commit. Add a reference to Google Map SDK. The problem with this commit is its position in the history, because we're adding a reference to Google Map after implementing a feature that is dependent on Google Map. So if we check out this commit and restore our application to this point, our application is not going to work, because at this point in time, in this snapshot, we don't have a reference to Google Map. So in this demo, we're going to grab this commit and move it down. It's super easy. So once again, we're going to start our rebase operation. So I'm going to grab the ID of this commit so we can see all the commits in our rebase script. Git rebase-i. Good. So we can see all of our commits from the oldest to the newest. Now I'm going to grab this commit, add a reference, and move it up. In VS Code, we can move a line up by pressing Alt and the up arrow. So like this. Now this commit is in the right position. So save the changes, close. Rebasing completed successfully. Now let's look at the log one more time. So first we add a reference to Google Map, and then we render restaurants on the map. This is much better, but we're not done yet. In the next lesson, I'm going to show you how to squash a few commits together. Now look at these three commits. Render restaurants on the map, fix a typo, and change the color of restaurant icons. All these changes are logically part of the same unit of work. So ideally, we should have encapsulated all these changes inside a single snapshot. But sometimes that's not possible because we work incrementally, and as we learn more about a problem, our solution changes. So we end up with several commits that are logically part of the same unit of work. So let's see how we can combine these commits together. So here's the first commit we want to work on. We're going to start with the parent of this commit, which is this commit over here. So copy this, git rebase-i. All right. So here's our first commit, render restaurants on the map. For the second command, I'm going to replace the pick command with squash. With this, Git will combine this commit with the previous commit. Now for the third commit, once again, we're going to use the squash command to combine this commit with the previous commit, which is the combination of these two commits. Now, if the commits that we want to squash are not directly next to each other, we can reorder them first and then squash them. So let's save the changes, close. Now Git is suggesting this commit message, which is the combination of the messages for all these three commits. So we have render restaurants on the map, fix a typo, and change the color. I'm going to discard these commit messages and keep the original message. Save, close, and we're done with the rebase operation. Let's look at our history. Our history is much cleaner now. We have a reference to Google Map SDK. After that, we render restaurants on the map. Then we update terms of service and so on. Now we have another command similar to squash called fixup. Let me show you how it works. So first I want to restore our history to the state before we started the squash operation. So we bring up our reflog. Look what we have here. The last entry represents the completion of the rebase operation. Before that, we had rebase pick again, followed by a couple of squashes, and this is where we started our rebase operation. Now we want to go to the previous state in history. So after we finish the previous rebase operation, so I'm going to copy this commit ID. Now, let's reset the head. Good. So to verify, let's look at our history one more time. We can see our original commits, like fix a typo and change the color of restaurants. Now let's start the rebase operation one more time. So I'm going to grab this commit ID and start an interactive rebase. So just like before, we're going to pick the first commit, but for the second commit, instead of squash, I'm going to use fixup. When we use fixup, Git doesn't take the message of this commit. So let's use fixup for the third commit as well. Save. Now when I close this, Git will take the message from the first commit and apply it to the commit that combines all these 3 commits. So we don't have a chance to craft a new message. Take a look. Close. We successfully completed rebasing. Next, I'm going to show you how to split a commit. Now look at this commit up here. Update terms of service and Google Map SDK version. These are 2 completely separate changes. Updating the Google Map version has nothing to do with updating terms of service. So we should split this commit into 2 separate commits. So I'm going to grab this commit ID. Now we start interactive rebasing from the parent of this commit. All right, here we're going to use the edit command that you have seen before. So when we close this window, Git will stop the rebase operation at this commit. Here we have a chance to split this commit into 2 separate commits. So close, back in the terminal, look, we stopped at this commit, update terms of service and Google Map version. Now let's look at the log one more time. So head is currently pointing to this commit. We can use the reset command to go back to the state before we made this commit. So we can type git reset --soft head ~1 or head caret. With this, we go 1 step back before we made this commit. So our changes are going to be in the staging area. Here we can unstage some of the changes and make a separate commit. Alternatively, we can go 2 steps back. So we're going to unstage our changes, but our changes are going to be in the working directory. Then we can stage and commit them separately. I'm going to go with this. Also, as I told you before, mixed is the default option. So we can simplify this command to git reset head caret. Okay, now let's get a short status. So we have 2 kinds of changes. We have some updates in package.txt and a new on-track file. So I'm going to stage package.txt and make a commit. Here we can say update Google Map SDK version. We can also say from 1.0 to 2.0. All right, now let's look at the history one more time. We have divergence. So we started our rebase operation at this commit. We wanted to replay these 2 commits. Now git stop before replaying this commit. Here we added a new commit, and that's why we have divergence. Now let's go ahead and make another commit for updating the terms of service. So we have a new on-track file. We can add it in the staging area and then make a commit. Here we can say update or add terms of service. Good. So we made another new commit that was not part of the history. Let's look at our log one more time. So here are the 2 new commits that we have created, and this is the commit that we're trying to edit. Note that in this demo, I didn't use the amend option because I didn't really want to amend or modify this commit. I wanted to replace this commit with 2 separate commits. So now when we continue the rebase operation, Git will replay the next commit. So git rebase -- continue. We're done with rebasing. Let's pull up the history one last time. So we have 2 separate commits, one for updating Google Map, the other for adding terms of service. So this is how we can split a commit. Now let's see how we can rewrite history using Git Kraken. So here's our Mercury repository that we started with at the beginning of this section. So all those bad commits that we talked about exist here. Now we want to start an interactive rebasing from this commit. So we right-click here and then go to interactive rebase. So we see a similar interface. Here we can see all the commits listed from the newest to the oldest. So for this commit, we can select rewarding and type the new message here. So render restaurants on the map. Update. We're done with this. We can move commits around. So here's the commit that adds a reference to Google Map. We can select this and drop it before rendering the restaurants. We can also squash commits. So I want to squash this commit into this commit. So here we pick squash. And now we can visually see that this commit is going to get combined with the previous commit. Also, I'm going to squash this commit into the previous commit. Super easy. We can also drop a commit. So for this commit, I'm going to set the command to drop. Now, when we start the rebase operation, we're going to see the same conflict as before. Because in this commit, we introduced a new file, terms.txt. If we drop this commit, we're essentially deleting that file. But then after this, we have another commit that tries to update that file. So let's go ahead and start the rebase operation. All right, we have a conflict on the right side. You can see we have a conflict in terms.txt. So let's select this. Here on the top, we have a few options. We can keep the modified version or delete the file. In this case, we're going to keep the modified version. So let's go with that and then continue rebasing. Good. So we're done with rebasing. That was super easy. But here we cannot edit a commit. So we cannot split it into two separate commits or amend it. For those cases, you have to go back to the terminal. So we're done with this course. Thank you for allowing me to be your instructor. I hope you learned a lot, and I'm going to see you again in my other courses. If you want to support me, please tell your friends and coworkers about my course and share your feedback on Twitter. I really appreciate your support. So that's it for now. I wish you all the best.